Try to spin around yourself as this dancer do. Spin for 1 minute or just for half minute. Then stop. Right now, what you feel? You will feel dizzy, vertigo, out of balance, or you might be fall. Why all that stuff are happening? In the semicircular canal, there is a fluid known as endolymph. When you're moving or rotating, the endolymph will displace and stimulate the hair cell, and this will send signals about the head motion and position to the central nervous system to make appropriate responses and reflexes to maintain our posture and balance. And in this case, when you're making a rapid movement or a violent movement, the endolymph will continue to move and stimulate the hair cell while you are stopped. So it will send the wrong signals to the central nervous system, and of course that will make wrong responses and reflexes, and because of that you will feel dizzy and out of balance. One of the most important functions of the vestibular system is to provide a perception of self-motion, which tell us where we are in space. The self-motion is the motion we experience as we actually navigate and move through our world. It determines the spatial orientation of our bodies in relation to the environment, and it allows us to distinguish whether the changing in environment happening around us is resulting from the body movement or from movement of the object. Okay, so this input from the vestibular system will combine with the central nervous system to allow functional motor activities. And of course, it's important to develop a gross motor activity because it depends on navigating on space. Be clear, imagine a swimmer crosses the pool with his eyes closed, and before he reaches to the wall, he will feel that he is close to the end and stop swimming or turn away from the wall. That's happening because the vestibular system is making him spatially weird and to don't hit the wall. Okay, so the vestibular system will send a spatial orientation perception or self-motion perception through the vestibulocochlear nerve, especially the vestibular branch, to the vestibular nuclei, then to the aureolar station, the thalamus, then to the cerebral cortex, and within the cerebral cortex it's making connections with different areas to make appropriate responses, for example in this case to turn away from the wall or stop swimming. So the self-motion and spatial orientation appeared in the difference between watching TV, which is a visual motion, or being inside the TV. I mean the virtual reality. The virtual reality is a self-motion because it allows you to being inside the environment, and actually the virtual reality can enhance the perception of the self-motion because the vestibular system in the virtual reality is more active than the other system that provide position sense and sensor information. The important function of the vestibular system is to control gaze or to make gaze stabilization. Gaze stabilization refers to control eye movement with head movement through a vestibular ocular reflex. This reflex will cause the eyes to move in the opposite direction to the head motion. As we see here, the head is rotated to the right side, and the endolymph in the right semicircular canal will displace to the opposite side and stimulate the hair cell, and that will cause to release a glutamate neurotransmitter, which is an excitatory neurotransmitter. After that, the neurons will send these signals, these excitatory signals, to the vestibular nuclei, then to the ipsilateral abducens nuclei and the contralateral oculomotor nuclei to contract the medial rectus muscle of the right eye and the lateral rectus muscle of the left eye to allow the eyes to move to the left, to the opposite direction of the head rotation. And of course, according to the retrovertical intervention, the opposite muscles will inhibited. Okay, and as we know, there's 3 semicircular canal in each side, and each semicircular canal is response to specific head motion. For example, the anterior semicircular canal will respond to nodding motion, like saying yes with your head. The posterior semicircular canal will respond to side motion, like saying yes in Indian. Okay, and the lateral semicircular canal will respond to a shaking motion, like saying no with your head. And the gaze stabilization is very important to maintain our balance, because imagine if you're running on the road and your body is going up and down and your head is going up and down. If your eyes going up and down with your head and it's not controlled by a vestibular ocular reflex, you will feel that the sky is moving up and down and the cars around you is moving up and down. So the gaze stabilization is very important to provide a clear vision during rapid head motion and to maintain dynamic balance. We learned that the vestibular system is provide necessary information to maintain our posture and balance. And we know that the cerebellum is the home of balance. So, of course, there is a connection between the vestibular system and the cerebellum. The vestibular system will send information about head motion and position to the cerebellum to influence eye movement, head movement, and posture. But the vestibular system by itself isn't enough to maintain our whole body posture and balance, so the cerebellum will receive information from other sources to coordinate and maintain our posture and balance to whole body. So why the vestibular system isn't enough to maintain our whole body posture and balance? Because the vestibular system is telling us that the head is moving or the head is rotating, but the somatosensory system will determine whether this rotation, for example, is due to neck or trunk flexion. Lastly, the vestibular system has a big role with motor control, and it's one of the most amazing systems in our bodies.